Have you ever wondered how the journey of science began? Our story takes us back to ancient civilizations, when the seeds of scientific inquiry were first sown. In the land of the pyramids, the Egyptians were pioneers of mathematics, architecture, and astronomy, their knowledge etched in hieroglyphs on sacred temple walls. Now, journey with us to ancient Greece, where the great minds of Pythagoras and Archimedes made groundbreaking strides in geometry and physics. Pythagoras, with his theorem, laid a foundation for mathematics, while Archimedes, with his principles of buoyancy, shaped our understanding of fluid mechanics. These early civilizations were not just building empires, they were building the very foundations of scientific thought, exploring the mysteries of the universe, and asking questions that would shape the world for centuries to come. This early period laid the groundwork for the scientific revolution that was to come. Fast forward to the 16th and 17th centuries, a period known as the Scientific Revolution. This era was a time of great change, with new ideas and discoveries that would forever alter how we perceive the world. The scientific revolution began with a bang, or more accurately, with a heliocentric model of the universe. This was a radical idea at the time, suggesting that the Earth and other planets revolve around the Sun, not the other way around. This was proposed by a man named Nicolaus Copernicus, an idea that was later supported by the observations of Galileo Galilei through his primitive telescope. Galileo's findings were so controversial, he was brought before the Inquisition and forced to recant his beliefs. On the other side of the Channel in England, another great mind was at work. Sir Isaac Newton, arguably one of the most influential scientists of all time. He formulated the laws of motion, and universal gravitation, which laid the groundwork for classical physics. His book, Philosophiae Naturalis Principia Mathematica, published in 1687, is considered one of the most important works in the history of science. But the scientific revolution wasn't just about astronomy and physics. There were also significant advancements in other fields of science. In biology, for example, William Harvey discovered the circulation of blood, and in chemistry, Robert Boyle laid the foundation of modern chemistry with his studies on gases. The scientific revolution was a time of questioning, of challenging the status quo. It marked the end of the medieval view of the world and ushered in a new era of scientific discovery. It was a time when science was no longer based on belief and conjecture, but on empirical evidence and logical reasoning. The scientific revolution marked a major shift in thinking, setting the stage for the modern era of science. Next, we enter the Age of Enlightenment in the 18th century, a time that witnessed a significant shift in the way people thought about the world and their place in it. This is the age where reason was championed as the primary source of authority and legitimacy, and where the scientific method began to shape the course of progress. The Enlightenment was a period of profound intellectual and cultural growth. It was a time of questioning and challenging the status quo, of seeking answers to the mysteries of the universe through logic and empirical evidence. The scientific method, a systematic approach to acquiring knowledge, became the bedrock of this new era. It was a process of observation, hypothesis, experimentation, and conclusion that allowed for a more rigorous and systematic exploration of the world around us. Two key figures stand out in this era. Francis Bacon, an English philosopher and statesman, who is often credited with developing the scientific method. He believed that knowledge was power and that scientific understanding could improve human life. His approach emphasized empirical evidence, the importance of observations and experiments in developing theories about the natural world. Then we have René Descartes, a French philosopher, mathematician, and scientist. Descartes is known for his philosophical statement, "I think, therefore I am." But he was also a pivotal figure in the scientific revolution of the Enlightenment. He championed the use of reason and logic in understanding the world, a principle that remains at the heart of scientific inquiry today. These thinkers and many others in the Age of Enlightenment helped to refine and advance the scientific method. Their work laid the foundation for many of the scientific principles and practice we take for granted today. They pushed the boundaries of human knowledge, challenging old beliefs, and ushering in a new era of scientific discovery and understanding. The Enlightenment refined our approach to scientific inquiry, leading to even greater discoveries. It was an age that proved to be a turning point in the history of science, a period that continues to shape our understanding of the world to this day. Now we arrive at the modern era, where science has truly taken off. This era has been marked by a series of groundbreaking discoveries, shattering previous conceptions and revolutionizing our understanding of the world. One of the most significant breakthroughs of the 19th century was made by a man named Charles Darwin. He proposed a radical idea that challenged the very foundation of our beliefs, the theory of evolution. Darwin's theory suggested that all species of life have descended over time from common ancestors, and it introduced the concept of natural selection as a mechanism for evolution. It was a daring leap that changed the way we looked at ourselves and our place in the natural world. The 20th century, known as the century of the gene, was no less revolutionary. Here, we witnessed the birth of modern genetics, a field that would further deepen our understanding of life. The discovery of the structure of DNA by James Watson and Francis Crick, with significant contributions from Rosalind Franklin, was a monumental achievement. This breakthrough paved the way for incredible advancements in medicine, agriculture, and many other fields. We began to understand the genetic code that defines every living organism, granting us unprecedented insight into the mechanisms of life. But the modern era wasn't just about biology. Physics, too, underwent a massive transformation. This period saw the development of quantum mechanics and the theory of relativity, challenging our perceptions of space, time, and matter. Thinkers like Albert Einstein and Niels Bohr played pivotal roles in these developments, pushing the boundaries of our understanding and expanding our view of the universe. And let's not forget the technological advancements that science has brought about in the modern era. From the steam engine that powered the Industrial Revolution to the silicon chips that fuel our digital age, science has been the driving force behind our progress. The modern era has seen the birth of the computer, the internet, and the smartphone, tools that have reshaped our society and how we interact with one another. The modern era has been a time of rapid progress and profound change, all powered by science. It was an era that saw the boundaries of our knowledge pushed further than ever before. Each new discovery has built on the last, leading us to a deeper understanding of the world and our place within it. But perhaps what's most exciting about the modern era is not just what we've learned, but the potential for what's yet to come. With each passing day, we're uncovering new mysteries, asking new questions, and pushing the boundaries of what we know. And with each new discovery, we're reminded of how much more there is to learn. The modern era has seen an explosion of scientific knowledge, transforming our understanding of the world. So, where is science heading in the future? The answer is as intriguing as it is expansive. Science, like a river, never stops flowing. It's always moving, always changing, and always pushing the boundaries of what we know and understand about our universe. One area we're seeing remarkable progress is in the field of artificial intelligence. Scientists are developing machines that can think, learn, and even create in ways that were once the exclusive domain of human beings. Imagine a world where AI can predict natural disasters with pinpoint accuracy or diagnose diseases before they even manifest. This isn't just the stuff of science fiction. It's a future we're building, piece by piece, with every algorithm and every line of code. Space exploration is another frontier where the future of science holds enormous potential. We've already sent rovers to Mars, landed a spacecraft on a comet, and peered into the furthest corners of the universe. But there's still so much more to discover. Propelled by advancements in technology, we're poised to uncover the secrets of distant galaxies, hunt for signs of extraterrestrial life, and perhaps even colonize other planets. The cosmos, vast and unexplored, beckons us to venture further and delve deeper. But the future of science isn't just about the next big breakthrough or the next headline-grabbing discovery. It's also about you, me, and everyone who dares to ask questions, seek answers, and challenge the status quo. It's about fostering a sense of curiosity, a hunger for knowledge, and a passion for understanding the world around us. So stay engaged, stay curious, keep learning. Because the future of science is a story that we're all part of. Every question we ask, every problem we solve, and every discovery we make adds a new chapter to this ever-evolving narrative. As we look to the future, one thing is clear: the journey of science is far from over.